So in our last class we discussed the transformation, inverse transformation 1.z. Okay. Now for this is z not equal to 0. So now this is continuous from the z plane not equal to 0 to the w plane where w is not equal to 0. Okay, and this can be extended to a transformation by including the 0 and the point at infinity. Okay, by so let us see by defining tz is 1 upon z, z is not equal to 0, and you notice that your limit of z tending to 0 tz is equal to infinity, since your limit your z tending to 0 1 upon tz, and this is equal to limit at z tending to 0. What is 1 upon tz? 1 upon tz is z, and we know that this is equal to 0. So when the limit z tending to 0, the function this is 0, that converges to 0, then therefore so limit of tz as z tending to 0 will be infinity. Okay, similarly limit tz as z tending to infinity will be 0, since limit as z tending to 0 t of 1 by z, okay, t of 1 by z, and that is equal to again limit z tending to 0. What is t of 1 by z? Your tz is 1 by z, so t of 1 by z is z, and that is also equal to 0. So limit of t1 by z as z tending to 0 is 0, so therefore limit of z tending to infinity, limit of tz z tending to infinity will be 0. Okay, so you can actually see page 51, okay, 51 of the text for more details, right? So you see that from here we can actually extend this tz for z equal to 0. So how? So we extend this by t0 is mapped to what? Infinity. Okay, t0, because this is z not equal to 0, but I can extend it to include z equal to 0, and you see that t of 0 is infinity, then t of infinity is 0. Okay, and what is your other tz's? Tz equal to 1 upon z for z not equal to 0. So therefore whenever we say that your w is equal to 1 upon z, so this is the transformation, then we tacitly assume that the point 0 and point at infinity, those are also included. So for this w equal to 1 upon z, in that case then the extended complex plane z plane will be mapped to the there is a one-on correspondence. This is the one-on correspondence between the extended complex plane to the extended complex plane w plane. Okay, so this z plane to w plane, because all points have one-to-one this correspondence with the points in the w plane. Okay, so we always take that z equal to 0 is also included, which is mapped to infinity, and point at infinity is mapped to 0. So therefore in our previous cases, when circles map to circles and straight lines map to circles and straight lines, there you will see that the straight lines passing through 0 or circles passing through 0. Okay, so we actually assume that your tz is defined by this. That means this has been extended to include 0 and infinity point. Okay, so next I will show some examples by using which we can see some images of certain cards. Okay, for example, so under this w equal to 1 upon z, how this so again you say that find the image, say find the image of image of y equal to c, y equal to 2 curves. Find the image of this. Okay, so for w equal to 1 upon z, we already got that under this your x equal to what, u by u square plus v square, where z equal to your x plus iy, and w equal to u plus iv, and your y was minus v by u square plus v square. Okay, so you see that y equal to 0, this is a straight line not passing through the origin. Okay, this is a straight line not passing through the origin. So what is this straight line? This is y x 1 and 2, so y equal to 2, so this is the straight line. This is the straight line in the z plane. So this is the straight line in the z plane. So to which curve this is mapped, okay, in the w plane. Okay, so what is this curve in the w plane? So that is to be found. Okay, and because your y equal to 2, so you see that y equal to 2, so this is the curve. So under this mapping, so under w equal to 1 by z, you will see that this is y is minus v by u square plus v square, and that is equal to 2. Okay, and that implies that this is nothing but u square plus v square. So 2 is there, you divide by 2 and plus, so it is v by 2 equal to 0. And if I complete the squares, then you will see that this is nothing but v plus 1 by 4 squared. Okay, and that is equal to 1 by 4 square, because 1 by 4 square is the extra term here. B square plus 2 times of this is b by 2. Okay, so your y equal to 2 is transformed to this one. Y equal to 2 is transformed to b plus 1 by 4 square equal to 1 by 4 square. And this is a circle. This is a circle. What is the center? Your center is 0, and v coordinate is minus 1 by 4. And what is the radius? Your radius is 1 by 4. Okay, so therefore in the w plane, your this is u, this is v, and your center is at 0 minus 1 by 4, so it is say 0 minus 1 by 4 minus 1 by 4. So this is the center, and what is the radius? 1 by 4. So this will go up to here, and that is your circle. Okay, that is your circle. And on the other hand, so if our half plane, you can say y equal to 2. So what is y equal to 2? So your y equal to 2 is nothing but this is 1, this is 2, y x, so y equal to 2, y is greater than 2, so y is greater than 2, and this is the half plane. Okay, so under this w equal to 1 upon z, to which region this is transformed? So you can see that from here, so minus b by this is greater than, now it will be what, minus b by u square plus v square is greater than 2, and that implies that so it will be less than, so e square plus v square plus b by 2 is less than 0. Then you will see that this is u square plus v plus 1 by 4 whole square is less than 1 by 4 whole square. So this is the circle. These are the points which are inside the circle now. Okay, so inside the circle. So therefore the upper half plane in the z plane, the half plane y is greater than 2 is mapped to what? The inside points, the points inside. And you can see that this is one of the cases, and that y equal to 2 is a straight line not passing through the origin, but your circle passes through the origin. Okay, y equal to 2 is a straight line not passing through the origin. Okay, it is a straight line because your a is 0 here in the general equation. Okay, and your d is not equal to 0, so that becomes a what? D is not equal to 0, So therefore in the W plane we have what, it is a circle, not it is a circle, and a equal to 0, so therefore it is passing to the origin. So that is the image. Okay, so we are getting that. So you can see the curves to which it is mapped. All right, thank you.